All right, I'm going to do these problems in little small sections. So let's do, say, like numbers 1 to 5 or 1 to 8. We'll see how that goes. All right, so these are true, false, but I'm going to go through them and explain them. So, number 1, when the difference between observed and expected sales, so what you found versus what was supposed to happen, can reasonably be attributed to sampling variation. Okay, that means it's happening just because from sample to sample, things happen to be a little bit different. Okay, so if it can reasonably be attributed to just because your sample is a little bit different than my sample, then the observed data, so then what you observed, is considered to be compatible with the null hypothesis. So that would mean, it's not far enough away to reject the null hypothesis. And so then that's why it's true, because it's just the very small variation because sample to sample. Okay, number 2. So I'm going to go ahead and do these in order, even though you had done the odds and the evens separately. Number 2, the chi-squared test statistic, the chi-squared, measures the extent to which the observed cell counts differ from those expected when the null hypothesis is true. So that's like saying, your p-value is the probability of getting this sample, these observed, or something more extreme when the null is true. And so that's what you are doing again also. You're measuring your chi-squared and how far what you got was away from expected. So that's true. Number 3, the distribution of the statistic chi-squared is closely approximated by a chi-squared distribution when the sample size is greater than or equal to 30. So this sample size being greater than or equal to 30 is referencing large enough for means. That is large enough for means, and that is not true. The large enough for chi-squared is that you have to see that all of the expected counts are greater than or equal to 5. Okay? So that is a false answer because it's large enough when the expected are greater than or equal to 5. All right, number 4. A chi-squared test can be used to compare the means of 2 or more populations, and that is not true. We've talked about how it cannot be averages, it cannot be quantities, quantitative values. It's only categorical, only proportions. Chi-squared can only be used with categorical and proportions, so that was a false answer. All right, number 5. The formulas for the expected cell counts and degrees of freedom for the chi-squared test, okay, so that's the chi-squared test, used to compare two proportions of 2 or more populations, okay, so that's like either the chi-squared test of homogeneity or independent, okay, are the same as those used in a chi-squared test of independence. All right, so if you're comparing the true proportion of 2 or more populations, that is the chi-squared test of homogeneity, and it's saying that you compute the expected cell count and the degrees of freedom the same for homogeneity test and independence test. And that is true. You do compute those the same. If it was talking about one population, that's a goodness of fit, okay? But this was talking 2 or more populations. All right, number 6. 2 outcomes are said to be independent when the probability that both occur is the product of their respective probabilities. Okay, so this is a way throwback into us being able to say that if A and B are independent, then the probability of A times the probability of B is the probability of A and B. So if the probability of A and B is the same as the individual probability of A times the individual probability of B, then those are independent of each other. Okay, that's true. That's a way back definition. You actually can kind of see that here on the formula chart. So I'm going to actually show you where that is. It's on the front side of the formula chart, and it's the regular one. So let's see if I can pull that up really quickly. And so the right-hand side, where you have probability, is shows you this, and that says probability of A given B would be this special thing, okay? You know what? In fact, I think that I'll just nix that little part. I think that that's going to get a little bit too confusing, so forget that, and we'll just go with that other basic concept. All right, stop there since I screwed that one up, and I'll start number 7 on the next video.